This is Team 38535A from Glenview, Illinois.
And this is our virtual skills challenge submission.
Because there's too much code to explain while the program is running, I will go over some key functions before I begin the narration. The robot uses the go to target function to navigate the field. It uses trigonometry and the distance formula to calculate how to get to a specific coordinate. An argument called getBall can be passed to this function. It subtracts 300 millimeters from the distance traveled to account for the length of the arm when grabbing balls. I will be referring to this function later on as the targeting function. The target distance function is used within the targeting function. It subtracts the target coordinates from the current GPS coordinates and uses the distance formula to calculate how far the robot needs to travel. The target angle function is also used within the targeting function. It calculates where the robot should turn to face the target by finding the absolute value of the inverse tangent of the target coordinates and the GPS coordinates. It then uses conditional statements to determine the heading the robot needs to turn to, as the heading changes based on where the ball is relative to the robot. This uses the GPS sensor to determine whether the ball is to the top right, top left, bottom right, or bottom left of the robot. The reverse version of the targeting function spins the robot by an additional 180 degrees and drives backwards. The fetch function intakes balls by spinning either clockwise or counterclockwise, and stops when the optical sensor senses that there is a ball in front of the robot. The robot bumps the ball at the top to get an extra 2 points. The robot uses the targeting function to approach the goal and score the preloads. The robot intakes 2 balls and uses the targeting function again to approach the goal and score. There is an array in the program containing the coordinates of all the tri-balls along the bar. The program uses a for loop to iterate through all the coordinates and score all the balls. Within the for loop, the robot uses the targeting function twice to go to the coordinates of the ball, and then the coordinates of the goal. The robot uses the launch function to shoot the last ball as it goes to the bottom left corner using the targeting function. The robot first bumps the ball on the bottom to get another 2 points. A for loop that launches 5 balls begins. The program uses the launch set function driving to a set launch coordinate and spinning the arm motor to the launch angle. The launch function then aims at the goal and releases the ball. Every time the robot launches the ball, the angle from which the robot shoots at the goal is incremented by 8 degrees. This prevents balls from blocking each other out of the goal. After launching, the robot uses the reload function to get another ball. After launching 5 balls, the robot goes to the bottom right corner and scores one last ball, backs up 200 millimeters to avoid touching balls in the goal, and the program stops. There's 74 points. An issue my team faced while working on autonomous code was that the robot did not turn accurately. We fixed this by creating a turn proportion variable that was multiplied to the degrees the robot was supposed to turn. Using this variable helped the robot turn accurately because it accounted for errors caused by the size of our robot's wheels. Working on virtual skills taught me to use variables to solve problems and improve consistency. We were also able to use the go to target function for autonomous skills, improving the positioning and accuracy of our robot.
And that's the end of our video. Thanks for watching.